If you don't know Sierra or haven't requested a quote from Sierra, please do so. We're in the Bay Area in Silicon Valley, and we have about 100,000 square feet of manufacturing. And we really work as a partnership with our customers on complex designs, both PCB and assembly. And reach out to us if you have a need. So today, this will be the agenda. We're definitely talking about laminates and stack ups and some, right ways to do stack ups and why stack ups are important. And then really understanding a fabricator's capability as much as you can upfront. And then of course, the main point of the webinar, I would say is the DFM and how to, understand DFM. And then, Valor will give a demo of that. Okay, so picking materials. Picking materials is definitely becoming a little bit more complex, and it really needs to be per what your design looks like. Um, so one of the key factors is, the material electrical properties, of course. So you want a decay less than 4, for faster signal propagation. You want to really take a look at, materials in this way if you have impedance requirements. And you also need to understand how the energy is flowing through the material, looking at the loss tangent of the material. So these are definitely important. Now, how your material performs versus the data sheet is different. So, getting input from the fabricator, in terms of the impedance modeling and uh, any kind of electrical performance is a key thing. If not everything performs to the data sheets. The other thing to look at is the CTE, or coefficient of thermal expansion. If you have design requirements like stacked laser drilled microvias, and you're picking materials that are not appropriate for that type of a design, then you're going to end up with uh, subpar, sub-reliable PCBs. And it's really because of the material you chose, is not working with the design that you have. So both these, the DK, DF, CTE, they go along with, what is your application, what is your design requirements, and not just isolated decisions. But a CTE is important in PCB manufacturing as well as on the assembly side. You want as few mismatches in CTE as possible. Okay, and the other one is TG, or glass transition temperature. We're getting lots of designs which have 3, 4, 5 lamination cycles. You have to be aware of the T sub G, because it can result in, all these kind of issues of cracked vias and, lifted pads, delamination, all these things can happen. So these are some guidelines for, choosing the right T sub G in your material as well. So, when you're looking for designing a stack up, and you have an idea of the HDI portion, you have an idea of the signal integrity that you want to achieve, you also have to create a mechanically good stack up, which basically means, you don't want to risk warping or risk any bending or flexing during the PCB process or even in the assembly process. There's a lot of boards that we're building right now that just require fixtures to hold the board, in place as coplanar as possible during the assembly process. Even if it's a thick board, it might be too heavy, or if it's a thin board, you know, an array is not enough to hold these boards in place during the assembly process. So understand your stack up and understand that there's no induced warpage in the stack up. And as we're building the product, if you have a core that has uneven copper distribution, like a 1 ounce and then a 2 ounce on the other side of the core, understand that that can impact overall yield. So knowing where the fabricator is going to be placing cores, and or as a designer, knowing where the cores are is critical. And then, of course, the tighter the distance between layers, you're going to have a better, coupling, and that's good for electrical performance. So,